Okay, so let's say you have a function, we'll call it h at x. H at x is equal to 6x squared times a to the power of x cubed. So this one looks a little bit scarier, but it's not too bad. And what we're asked to do is find the integral of h at x dx. And as you can see, there's no intervals here, so what it's asking for, it's just asking for the indefinite integral of that function. So let's go ahead and do the same thing as we did before by setting our placeholders. So in this case, a to the, our box here is going to be this x to the power of 3. So placeholder is going to equal to x to the power of 3. And then our derivative of that placeholder with respect to x is going to equal, using our power rule, 3x, and then reduce the exponent to 2. From this point on, we can go ahead and start working on this integral. So we write our integral sign here. Okay, so this is what we're asked to find. 6x squared times a to the power of 3, or sorry, times a to the x cubed dx. And now what we want to do is we want to substitute our placeholders in. So what this will equal, okay, because we want to get it, we want to get into that correct form. So we're going to substitute, okay, so we're going to have 6 times x squared times a to our box dx. But as you can see here, we want to be integrating with respect to this box here, right? So what we're going to do is we're going to come in and multiply this this derivative here. So what we'll have is 6x squared times a to the box times d box by dx dx. And again, you can visualize these dx's canceling out. So now this is in a proper form. So you can go ahead and substitute our numbers back in. So we have 6x squared times a to the x cubed times, okay, d box by dx times 3x squared. Now, as you can see here, we already have 6x squared here. So if we want this to be multiplied by 3x squared, what do we have to multiply this term by, okay, so that this right here will be equal 3x squared? Well, the answer is 1 over 2, right? So 1 over 2. So if you multiply 6x squared times 1 over 2, you get this here. Right? And then dx. So we're almost there. Okay, so now as you can see, this is in a proper integrating form. Okay, it's in this form here. But the problem is, now that we've added this 1 over 2, okay, this expression does not equal our initial expression here. Okay, so what we can do to massage that is just multiply it, make this 2 cancel out, so we're going to multiply it by 2. Okay, now it's in a good form. So a sleight of hand that we can do is you can take this 2 out of the integrand. So we'll go 2, just going to scroll down just a tad bit here. Okay, so we're going to go 2 times the integral of 6x squared, or sorry, I shouldn't say 6x squared. I should make it 3x squared. Okay, but I'm going to write this first. I'm going to write a x cubed. Okay, that's this right here. And then these two together, okay, this is going to be 3x squared, 3x squared dx. So as you can see now, this is in a perfect form, because what's happened here is that this integrand here is in this form here, right? So a to the box, okay, is equal to a to the x cubed, and this derivative with respect to x, okay, is this right here, this 3x squared, good, dx, and we have our dx here. But on top of that, this entire expression, okay, this entire expression is equal to our initial expression here. So, there we go, is equal to that whole expression. So we're good to go. So that means we can just simply convert this to this. So that means that we'll get 2 times a to the box, or times a to the x cubed, divided by ln a plus c. I'm just going to scroll down a little bit here. And that would be our answer here. Okay, that is our answer. A slightly more complicated question, but again, it's all about just following the steps and understanding how to convert your integrand into this form here, while also making sure that the entire expression doesn't change. So that is how you calculate the integral of a general exponential function.